Okay, so this first section, what we're going to do is talk mostly about some definitions around some terminology around graphing and the rectangular coordinate system, and then we're going to end up talking about the distance formula and the midpoint formula. All right, so when we talk about the rectangular coordinate system, this is the next level of graphing that you have after the number line. When we just had x, we could, one real number, we would put it on a number line, it had a location, and that's it. Now if we have two variables, we'll call them x and y, or they can be any variable, we put them on a rectangular system like this where we have two independent variables. So we're two variables that we graph in an ordered pair. So traditionally we have the horizontal axis as the x-axis and the vertical axis is the y-axis. In the absence of anything else, that's what we use, but if you have other variables in there, you can graph them so long as you label them. So you'll notice in most of the word problems that I've been doing, like two on the board here, I've been using T and A and different letters. I encourage you to use different letters because ones that remind you of what the variable really is. And so if you're doing a time and distance problem, perhaps you would make the horizontal axis T and the vertical axis D. And so for that reason, since you can have different variables, when you're making sketches of rectangular coordinates, I'd like you to make sure that you're labeling what is what. You could put y on the horizontal axis and x on the vertical axis. That's unusual to do, but nevertheless you can do it. So really, even if you're using the most common variable and the most common orientation, still label them x and y. And all you have to do, you don't have to write an arrow like I showed here. All you have to do is write an x somewhere out here and a y somewhere up here to show that those are the x and y axes. We call the intersection of these two axes the origin. And what we're putting on here is an ordered pair. Now the important word here is that it's ordered. That means it has an order and you have to stick with this order where the first value is what gets plotted on the x-axis or on the horizontal axis. The second value is on the vertical axis. And just to make life easy, we have names for the four pieces of this graph. The one where we spend a lot of time because we have just positive numbers here like this, we call that quadrant 1, and we go around the areas in a counterclockwise fashion where this is quadrant 2, quadrant 3, and quadrant 4. And the reason why we number them in that order is more related to trigonometry than anything else, where when you have angles that start at the x-axis and they start increasing, they'll go from the first, second, third, and fourth quadrant around. So we're not going to really do anything like that, but it's handy to know what the names are, so you can say, well, here's a point in the third quadrant. Then you know it's going to be somewhere down in here. All right, so let's see what the basis of making these graphs is. And if we look at the first ordered pair, we have 2, 3. The 2 refers to the x value, the 3 refers to the y value. And so our x value is going to be 2, the y value is 3. But it's not the point on the axis like we did with a number line. What it means is that any value that's along a vertical line along here has the value x equals 2. And any value that's along a horizontal line that goes through 3 is y equals 3. And so the coordinate point then is going to be where they intersect. So there's our vertical and horizontal lines. So where they intersect is where this point is. It's a single point, and it's uniquely located there. So when we have negative values, we just make the vertical line on the x-axis at the negative line, and we go up to this horizontal line, which represents y equals 4, And so this point then here is the coordinate pair -3 and 4. Now the axes are perfectly good places to graph things. If we have x equals 0, that means we're somewhere along the y-axis, right? Where since the y-axis is located at x equals 0, we'd expect it to be along the axis somewhere. And then where y equals 2 is at this point, so 0, 2 would be plotted right there. And similarly, if we have 4, 0, that would be where x equals 4 and y equals 0, which would be this point here. Now, I mentioned the origin in the last slide, and so if we look at the origin, that's at 0, 0. And so that's, you know, the logical place to start everything, and that's why it's called the origin. Any questions? So it's terminology. Hope you've seen it all before, and just kind of reviewing at this point. So we're going to learn several ways of plotting things, and there's one really fundamental basic way to do things if you know nothing else about how to plot, and that is just making a table of values. And so we choose x. X is the independent variable, and then the value of y depends on x, so we call that the dependent variable. And so let's say we want to plot y equals x minus 1. The way we'll do this is we make up a table of x's, and we just choose some arbitrary points that we're interested in, and then evaluate y at that value of x. So if y equals x minus 1, we have -3 minus 1 is -4. And so these represent the coordinate pairs. And you don't have to write the coordinate pairs. The table is sufficient. We know what it's suggesting. So you know, if we have x equals 2, y equals 1, that's the coordinate pair 2, 1. And so when we draw our axes and plot it, we get this nice orderly line of points, or all the points are in line, and we connect the points. Now, we just chose the points of x arbitrarily. We could have picked fractions, we could have picked, you know, anything in there, any value for that matter. We just chose what was convenient. And so what's implied in that choice is that every point in between there belongs on this graph as well. So this graph does not represent the complete set of numbers that corresponds to this particular equation. It's everything, all those points and every point in between them. So the points there are really just a matter of an aid to help you draw what the graph looks like. The actual graph of y equals x minus 1 is the line. And so if you choose to do this just to be a little bit less conspicuous about your points, if you want to make a real fine point, you know, so the line ultimately covers up, it's perfectly good, you know, and that's probably a little bit more accurate. What it's suggesting is that it's a line and not these uniformly spaced points. All right, any questions on this? Okay, so let's talk about now the distance formula and where this comes from. Remember, the distance between two numbers on a number line is the absolute value of the difference, right? We take the absolute value because we want all our distances to be positive. And we just take the difference between the two of them, and that's the number of units in between those 2 points. With our coordinate pairs, it's not quite that easy. Because let's say we have these 2 points, 2, 1 and 6, 4. You draw a line, and what's the length of that line? Well, it's a single number. It's not a coordinate pair, certainly, so we have to do something that involves both x and y. And so what we do is, let's lay this out as a triangle. And so if we look at the base of this triangle from x equals 2 to the point directly below 6, 4, which is 6, 1, this distance is 4. And then from this point, where y equals 4, down to y equals 1, which is at the same level as 2, 1, we have a difference there of 3 units. Okay, so the length of this line is 3, the length of this line is 4, or excuse me, the length of this line is 4, and the length of this line is 3, and we know we have a right angle because we set up our coordinate system to be everything's at right angles. So then, if we remember the Pythagorean theorem, the sum of the squares of the two sides equals the square of the hypotenuse. And so we can plug those in, and we get the distance is going to be 3 squared plus 4 squared is 9 plus 16. Take the square root of that, square root of 25, and we get 5. So this is okay to calculate it like this, but we can reduce it to a single formula. Remember, A was the difference between x's, and B was the difference between y's. We can write the whole formula as this. Now, of course, I had A as my distance. Yeah, I do have it in the right order. The differences between the y's squared, differences between the x's squared. Now, the difference between x2 and x1 can be positive or negative. And since the Pythagorean theorem says we need to square it, we know we're always going to end up with a positive number. And that's a good thing because we want our distances to be positive. So it doesn't really matter which point you choose as x1, y1, and x2, y2. You just take the differences of your y's, take the differences of the x's, square them, add them together, and take the square root. All right, so that's the distance formula. So you have to memorize this, right? It's not difficult to memorize. Just remember it's the Pythagorean theorem. We take the differences to get the distances, square them and add them together, and then take the square root, and we'll get that distance. Okay, and then we have another thing that we want to know generally about points on a plot, and that's what's the halfway point between the two of them. This is the midpoint formula. So again, if we have our graph with our 2 points, what is the point that's in the middle? And you're going to expect that that point is going to lie along the line that connects those 2 points. So let me have you consider this. Let's say I'm going to draw a diagonal along this, the back of this notebook, and I'm going to figure out where the middle is. All right, I'm going to look at the middle. So if I took this thing on the edge and I looked at it this way, so all I'm seeing is the length of the pad and where that point is going to be halfway in between both of those sides, right? And then if I look from this end, I'm going to see the same thing, where that point is going to look like it's halfway between these two sides. And so that's the whole key to the midpoint formula, is that the midpoint for the x-coordinate is just the average of the two. It's the midpoint between the x's. The midpoint between the y's is just the average of the x's, which will give you the midpoint of the for the y value. And so here, if I draw the edge of my pad here, where if I put this 4, 1, where I'm going to go straight over from 1 and straight down from 4, I'll get this point. Halfway here, I know my midpoint is going to lie along x equals 3. And if I do the same thing for my vertical value, it's going to be halfway in y, which is the same thing, where 5 plus 1 divided by 2 is going to be 3. So you see that the midpoint is going to be at y equals 3. And so we'll just call that midpoint in coordinate pairs 3, 3. So the formula for this is, and don't look at this as memorizing a formula. Understand the concept that the midpoint between 2 points is the average of the coordinates. Okay, so then it comes out nicely where it's going to be the sum of the x's divided by 2 and the sum of the y's divided by 2. So the thing to be careful with is that with the midpoint, you're looking at the sum of the x's divided by 2. With the distance formula, you're looking at the difference of the x's and the difference of the y's and square them. So with distance, remember it's difference. With the midpoint, it's the average, so you're going to add the 2 and divide by 2. Okay? And that's the best way that I can tell you to to remember that, because you do, after all, have to memorize this. And so, you'll use this in a variety of things in this course and a little bit beyond. Okay, so how does it look? Any questions on those? So you have the coordinate system, distance formula, midpoint formula. So what I'd like you to do is calculate the distance and the midpoint between these two points.